Question 1. It's going to be a long video. We want to write inequalities. So Sam needs to collect at least 200 water bottles. So right off the bat, I know it's going to be this. It has to be 200 or more for a science experiment. She has to collect 55 so far, so I can start filling. So she has done 55 plus. She starts with 55 plus her Sam and her 2 brothers are going to collect bottles this weekend. So that's a total of 3 people. So 3 people are going to go collect bottles, and they're each going to collect the same amount. So 3 people times the number of bottles they're going to collect plus the 55 they already have has to be greater or equal than 200. So how many bottles do each of the 3 people have to collect? And that's your inequality. Well, minus 55, minus 55. 3b comes down, greater or equal to 145. Do we have a calculator? Yes, I do. You will have one too. Divide both sides by 3. And 145 divided by 3 equals, so the number of bottles that each person has to collect is 48.3. Right, so if we graph this, here's 48.3. Has to be shaded. But you can't collect. So in the context of this story, you can't collect 48.3 bottles. Each brother can't collect 48.3 bottles. So the minimum number of bottles that they each will collect, they each need to collect 49 bottles. And that's the answer for this particular problem. Again, context of the story. Okay? So that's 1. 2, the one right next to it, it's Tim problem. Tim wants to earn $800 this week. He's paid a salary of $340 plus $35 for each laptop. Write in solve inequality to find the least number of laptops that he needs to repair to reach his goal of 800. So again, he has to be greater than 800 or, in this case, even equal to 800. So he already has 340, so it's pretty much the same as the previous problem. 340 plus $35 for each laptop. So the question is how many laptops he needs to fix. Well, 340 here, 340 here. We get 35L greater or equal to 810 minus 340, 470. And divide both sides by 35. Divide by 35. And the number of laptops that he has to fix in order to reach his goal is 13.42. Well, so he needs to fix 13.42 laptops. If he fixes 13, that's not going to be enough. So, again, graph this. We're going to have 13.42 shade. But because he can't fix 13.42, the minimum, right, the least number of laptops he needs to fix is 14 laptops. Okay. Cameron goes to the market. He's going to buy cans of chicken soup and loaf of bread. The loaf of bread $3.49. Each can of soup is $1.29. The most he can spend is 12. So how many cans of soup can he buy? So again, I know the problem is rather simple, but it's about you setting up the inequality too. So you need to set up the inequality. So the most he has to spend is $12. So has to be less than 12 or equal to 12. He's buying 1 loaf of bread, and that's our constant. Plus, how much is each can of soup? $1.29. $1.29, and I'll write C for cans of soup. So minus $3.49, minus $3.49. 129C is going to be less or equal to $8.51. So after the loaf of bread, he has $8.51. We're going to divide that by 129, divide that by 129, and C, the number of cans of soup divided by 129 is going to be 6.59. So think about this for a second. Let's graph this for a moment. So he can buy 6.59 cans of soup, but right, up to 6.59 cans of soup he's able to buy, but he can't buy 0.59 of a can. So the maximum number of cans he can buy, he can buy up to 6 cans. Next one, and the next one is the other problem, but I shifted that problem down to the equation section, so we're still in the inequality. So Winston needs 80 signatures, at least 80 signatures. So let me start setting it up. It has to be equal to 80 or greater. He has 23 already, so there's my constant. It's plus in this case. He and two of his friends are going to get the remaining signatures during lunch. How many signatures must each person get? And assuming that every person gets the same amount, so we have 3 people, and I'm going to use, I don't want to use S. I'll use S for signatures. Okay, what's the minimum number of signatures each people should get so he can run for class president? Well, minus 23, minus 23. 3S is greater or equal to 57. I'm going to divide this by 3, divide by 3. So the number of signatures each person needs to get, and divided by 3 is, well, this one works out nicely. 19. Here is my graph. So you need the graph. All right, so 19 and above, they meet their quota. So if each person gets 19, at least 19, right? So, and then you can double check. You put 19, so here's my inequality, 23 plus 2s greater than 80, 3s, sorry. 23 plus 3 times 19 greater or equal to 80. 23 plus 57 greater or equal to 80. And notice that that makes my inequality true. So with 19 signatures, they meet the requirement. Okay. Santino, he needs 406 forks for his restaurant. So 406 forks for his restaurant. He currently has a total of 278. So he has 278. Let's start setting it up. Each set of forks has 12. What's the minimum number of sets he should buy to reach? So it has to be greater or equal to 406. And again, it's a plus. Sorry that all these questions are adding. I should add some subtraction. But 12 forks per set. And this is what I'm looking for. How many sets? So minus 278. Minus 278. 12s greater or equal to 406 minus 278 equals 128. Divide that by 12, divide that by 12. The number of sets he needs is 10.666, 10.67 around it. Now, you can't, so he needs 10.67 sets. All right, so at 10 sets, he's going to be short, so he needs the 0.67. So let me graph this. He's going to be short. 10.67, he's going to be short. So at 10 sets, he's going to be short. So the minimum number of fork sets is 11. And that's the answer in the context of this story. So again, let's do our check. And I keep forgetting to do the check, but you should. 278 plus 12 times 11 is going to be greater or equal to 406. Hopefully that's true. Let's see. 12 is 11. Sorry. So we got 278 plus 132 greater or equal to 406 plus 278, and we get 410. So if he gets 11 sets of forks, he's going to have 410, right? So which he's going to meet, right, the total of 408, and he's going to have a few left over. Okay. So those are the inequality questions. And again, please, actually there's one more, but please go over not only these questions, but the other check for understanding questions. Okay. So we rent a car, Sam. The charge is $28 a day plus 15 cents per mile. He has only $240, so that means whatever he spends here on this car rental has to be less or equal to $240. What's the greater number of miles he can drive? Well, what is he going to spend on the car rental, just the rental itself? It's 28 times 4, right? And that's going to be $112. So $112 plus 0.15 per mile. Well, minus 112, minus 112. So from the 240 that he has left, that he has to spend, we're going to take the car rental charge. So 240 minus 112, and that's going to leave him with 128. And that's how much he has left. Right, so how many miles can he drive with $128 and every mile costing 15 cents? So let's divide this by 0.15. And that's going to give us 128 divided by 0.15. Wow, you can drive pretty far. 853 miles, 0.3, right? So graph this. Now in terms, so this one's a tricky question. I should have been more specific because you can actually drive 853 point, depending on your odometer in your car. Next time you go in your car, it actually shows you you've driven 100 miles, 100 miles, 0.1, 100 miles, 0.2, right? It actually gives you the 10th, right? So the maximum number of miles, whole miles, would be 853. But if the question allowed for decimal, fractional part, it'd be 853 and 1/3 of the next mile. Writing an equation. So here is the Miss Garland question, right here. It's an equation. Miss Garland bought X number of shirts. The cost of the shirts is $3.99 for shipping. The cost of X number of shirts, including $3.99 for shipping, was $77.49. So he spent $77.49. What equation could be used to find X? Maybe this should have been an inequality, but let's just see what we have. So it's $3.99 for the shipping plus 12.25 per shirt. So equals that. Now, minus 3.99 minus 3.99. This should give you, the answer should have been a whole number, by the way. So 77.49 minus 3.99, that's going to give us $73.50. We're going to divide that by 12.25, and I hope that gives us a whole number. Divided by 12.25 equals 6. Oh, good. So the total number of shirts that were bought were 6. And again, you can do a check. 3.99 plus 12.25 times 6, and that should give you $77.49. You're going to have a calculator, so just multiply 12.25 times 6, enter, and then plus the shipping, $3.99. And guess what? It's exactly the same. So we know our answer is correct. Sorry. One second. Sorry. Where am I? The mechanic. So we had a mechanic, and the total cost for fixing the car was $329. And what did that $329 include? Dollars included? It included $248 for the brakes, plus the 3 hours of work. 3 hours. 3 hours times whatever he earns, right? So I guess I will call it cost per hour. 3 hours, and we don't know how much he charged per hour, so I'll put C. Minus 248, minus 248. That goes away. 3C equals 329 minus 248, which is 81. Divide by 3, divide by 3. And the cost per hour for the mechanic was 27. So the mechanic cost to charge $248 for the brakes, and then $27 per hour that he worked on the car. So again, just do a quick check. All right, and then it's 248 plus 81 equals 329, and then notice that left side equals right side, so we're good. Mark, setting up a tent. The tent came with a 10-foot rope, so he needs to use 33.5 inches of the rope to tie tarp to the top of the tent. So now, first of all, 10 feet, we're going to have to change that to inches. It's 120 inches. Okay. So we have a tent. Okay, and I got a rope here, the top of a tree. Wait, tie a tarp on the top. So this is the tarp on top of the tent. So let's just assume that this guy is 33.5 inches. So everything is equal to 120, right? So we use 33.5, and then plus, we're going to see how many of these, the leftover rope. So let's just make it like this. So this is 120 inches. Okay, this much, what do you use to tie the tarp? Tie the tarp. So you have this much left over, and how many here, how many 8.5 inch sections can we have? How many 8.5 sections can we make with the leftover? Okay, so 33.5 plus 8.5x equals 120. So let's subtract 33.5, subtract 33.5, and we get 8.5x equals 120 minus 33.5 equals 86.5. We're going to divide both sides by 8.5. So 86.5 divided by 8.5, it's going to give us, so we can make x equals 10.18 rounded, okay? So not exactly 10.18, which means I can have 8.5 sections. 1, 2, 3, sorry, not 8, 10. 4, 5, 6, 7, 8, 9, 10. So I can have 10 of these sections, each measuring 8.5, 8.5. Right, and the next one would be 0.18, okay, of 8.5. So we have, and that's our answer. But in the context of this story, I guess we can only have 10 8.5 inch sections. Okay. All right, so far it should be pretty simple. Yeah, a couple more. Todd orders pictures from a photographer. Each picture costs $7.50. A one-time shipping fee of $3.25. The total cost of the order was $85.75. How many pictures did Todd order? Write an equation. So the total was $85.75. What was included in this amount? It was the shipping fee, a one-time shipping fee, plus 7.50 times the number of pictures. All right, and call it X, call it P. Let's subtract 325 from both sides. We're going to have 750. X equals 82.5. We're going to divide both sides by 7.5. And X equals 82.5 divided by 7.5 equals 11. So how many pictures did he order framed? 11 pictures. And again, do a check. 7.5 times 11 equals 85.75. 3.25 plus 82.5 equals 85.75, and you can tell already that left side equals right side. So two expressions equaling each other. Very good. Sam says that in the following equation, equals 3/4 of m plus 12 equals 24. The first step here, she said she divide both sides by 3/4. So the first thing that she did was divide both sides by 3/4 to start the problem. Would you agree with her? Well, let's do that. Let's actually see what happens. Now in class, we talked about clearing the fractions, and if we wanted to clear a fraction, we would divide this by 4. Sorry, multiply that by 4 and that by 4. And guess what would happen here? This and this would be eliminated, and we would get rid of the denominator, so no fractions, and then we multiply 24 times 4 on the other side. But what this lady did was something even, I think, better. She says, I'm going to take this side and divide by 3/4. And I take this side and divide by 3/4. Now, it's a, what do you call that, complex fraction, right? So dividing by 3/4, so 3/4 divided by 3/4 is actually the same, right? So let me write this problem again. So if we dividing both sides by 3/4, isn't that the same as multiplying by the reciprocal, which is multiplied by 4/3, right? Dividing by 3/4 the same thing as multiplying by the reciprocal. So multiply by 4/3 on both sides. So well, look what happens on the left side. She got rid of all this. It's gone because they all become 1, 1, 1. And on the other side, 24 divided by 3 is 8 and becomes 32. So in essence, she made this problem much easier. Look, she left with a one-step equation. And then what will be next? Well, subtract 12, and m equals 20. Let's check. Well, if we were to check, we would put the 20 in my original equation, right? In the original equation, we put it over here. Well, let's see what happens. So 20 plus 12 is 32. And what's 3/4 of 32? So we get 32 inside, right? So let me just 30. And then if you multiply 3/4 times 32, 3 divided by 4 is 8. And 8 times 3 is 24. Look, this 24 is the same thing as a 24 on the right side. So would you agree? Why would she do that, and do you agree with her? Well, she did that to get rid of not only the denominator, but right, the numerators as well. So she turned this into a simple one-step equation, right? Nice gimmicking, right? Nice, very smart. Solve and check. Negative 3x. Again, it says solve and check, guys, please. Negative 3x minus 4 parentheses 4x minus 8 equals 3. Negative 8x minus 1 parentheses. All right. Negative 3x minus 16x plus 32 equals negative 24x minus 3. Combine like terms, we get negative 19x plus 32. Sorry, I forgot the x here. Minus 24x minus 3. Let's get rid of the minus 24, and we're going to do plus 24x. Plus 24x. That goes away. I'm left with 5x plus 32 equals negative 3, minus 32 on both sides. I get 5x equals negative 35. Divide both sides by 5, and x equals negative 7. I think that's the easy part. X equals negative 7. So now we got to do a check. Let me erase all this. I'm going to replace every x that I see with negative 7. So negative 3 times negative 7 minus 4. 4 times negative 7 minus 8 equals 3 times negative 8 times negative 7 minus 1. Oh my god. Let's do the right side because it looks easier. So negative 8 times negative 7 is positive 56. 56 minus 1 is 55. And 55 times 3 is 165. So I get 165 on this side. On that side, this is 21, right? Because a negative and negative is a positive. Minus, let's see, 4 times 7 is 28. 28 minus 8 is 20, so that becomes 20. Negative 4 on a second. Did I do something wrong? So sorry, this is -7. -20 and -28, right? So I actually get -4 times -28. There we go. That was my mistake. 4 times 28 equals 112. Hang on. Let's see. -20. Oh my God. Sorry. Hang on a second, guys. I made a mess of this check, so let me do the check again. So it's -3 times -7 minus 4 times 4 times -7 minus 8. Okay, there's no mistake again. 3 times -8 times -7 minus 1. Let's do the right side. 8 times 7 is 56. Positive 56 minus 1 is 55. So 3 times 55 is 165. So the right side is okay. On the left side, -3 and -7 is positive 21. Minus 4, and let's do this in steps. 4 times -7 is -28. -28 and -8 is -36. So now I get to do 21, and then 4 times 36. It's going to be positive because, right, I'm going to add plus 144 equals 165. And then if I add these two, I actually get 165 equals 165. Okay, so that's okay. What's the next one? Next one, 4, 2a plus 3 equals -3, a plus 1, sorry, a minus 1, plus 31. 8a plus 12 equals -3a plus 3 plus 31. 8a plus 12 equals -3a plus 34. We have variables on both sides. Let's get rid of the smaller one. So 3a plus 3a on both sides. That goes away. 11a plus 12 equals 34. Minus 12 on both sides. 11a equals 22. Divide both sides by 11. A equals 2. Now we have to check. So I'm going to erase everything. You guys can use the forward or rewind button. So x equals 2. 4 times 2 times 2 plus 3. And on this side, -2. 2 minus 1 plus 31. Alright, 4 times 2 is 4. Plus 3 is 7. 7 times 3 is 28. So I get 28 on this side. On this side, I get -3. 2 minus 1 is 1. Plus 31. 28 equals -3 plus 31. And guess what? We are good. All right, so that's that. And then these two, okay, so this one we'll talk about a little bit. -4, 1 minus 6a, so let's do the distributive property. 24a minus 22 equals -4 plus 24a. Right, so notice, and then right here, you should ask yourself, oh, or notice that it's almost the same expression on the left side and the right side. Let me just rewrite this. So 24a minus 22. On the right side, it's 24a minus 4. So the left group, we're multiplying 24 times a number and then subtract 22. On the right side, we're multiplying 24 by that same number, but subtract 4. So there's actually no way that this will ever equal this. Because although we're multiplying 24 by the same number, one side I subtract 22, the other side I subtract 4. So to continue, right, so if you notice that already at this stop, you can say, hey, this is not going to be, there's going to be no solutions to this because, well, the next step here, well, what will we do? We will subtract 24a on this side, subtract 24a on this side, right? That goes away, and we're left with negative 22 equals negative 4. And that tells us that there is no solution to this problem, okay? 12, 2k plus 11 equals 12, 2k plus 12. Plus 12. So here we have 24k plus 132. And here we have 24k plus 144. And again, it's the same problem as before. You'll notice that this expression is very similar to the expression on the right, except that on one side, I'm going to add 132. On the right side, I'm going to go add 144. Sorry, 1 second. Minus 24k, minus 24k, and again, this becomes a problem similar to the one we did. You'll notice that we get 132 equals 144, and that's never going to be true, right? So this is, again, a no solution. Let me step back here. Let me see if I can go back. Let me change the problem just a little bit. Let me, here, 2k, and let me make it 11. So let's say you do this truly properly. I'm changing the problem. 12 times 2k is 24k. 12 times 11 is 132. And at this point here, you'll notice that this expression, the left one, is exactly the same as the expression on the right. So now this one, right, again, think about two expressions. On the left side, well, let's say k equals, I don't know, 1. Just make it very easy. So 24 times 1, add 132. On the right side, 24 times 1, add 132. Let's make k equals 10. 24 times 10 plus 132. The right side, 24 times 10 plus 132. So you're multiplying 24 by the same number and then also adding the same amount to both sides. So in this case, well, when we do minus 24k on both sides, look what happens. We get 132 equals 132. It's telling us that this one is all real numbers. K could be any value in this world. The left side will be equal to the right side. Okay. Combine like terms. So there's one silly question on combining like terms. But you already know how to do it. So the first thing before we combine like terms, we gotta get rid of the parentheses. And we do that by doing the distributive property. So if you want to imagine there's a 1 here, go ahead. We get negative 15a plus 45h. And then positive and negative is negative 12a. And then positive and negative, negative 33h. Combine like terms? Yeah, I can combine this guy with this guy. And I get negative 27a. Please make sure that when you identify your term, the like terms, that you include the sign that precedes the number, right? So this negative, it's not positive 12a, it's negative 12a. And that's how I got negative 27. And then I have positive 45h minus negative 33h. So that's going to give me positive 12h. And that's my final answer. The next one is negative 4, negative 9m minus 5 minus 9, negative 7m minus 12. So again, distributive property, right? 2 places. So 36m plus 20 plus 63m plus 108. So negative and negative is positive, negative and negative is positive. Like terms, yeah, this guy here and this guy are like terms. They're both positive. Makes my life so much easier. And it's 99m. And then positive 20 and positive 128 is just 128 in total. Okay. That's that. And then we have a few more problems. More problems at the bottom. Represent with inequalities. So the first one, her weight is greater than 105 pounds. So here's W, represent her weight. It's greater than 105. Possible. So we're going to graph this. Here's 105, and greater than 105 is this. So her weight could be anything above 105. Possible solutions: 106, 105.1, 120, etc. Where am I? Maximum speed. The maximum speed in school is 25 miles per hour. So the speed, I want to use as, has to be less or equal to 25. Graph. Oops. There's 25. We want to shade, and the speed of the cars can be 25 or less. Possible solutions: 24, 23, 20. Right. And my TV has less than 10 channels. So here is less than 10, and here are the channels. So 10, shade, not shade, and we're pointing to the left. Make sure you put arrows here. Okay, that's one point off if you don't put arrows, because then the number line continues forever to the left and to the right. So possible solutions: I could have 9 channels, 8 channels, 2 channels. Right? In the context of the story, right? You're not going to write negative, although it's part of the solution. She earns more than $1,500 per week. Earns E greater than 1,500. So in this case, here's 1,500. Not shading because it's above 1,500. So she can actually earn 1,501 cent, 1,550, 2,000. All possible solutions. Okay. All right. 3 consecutive integers. So there's 3. Let's identify them. So x plus 1, x plus 2. So that's how I was sort of identifying my participants. Such 3 times the smallest, so 3 times the smallest, which is x, which is equal 14 more than the largest. 14 more, which means addition, and the largest is x plus 2. Don't need to put parentheses. Now, notice that, no, notice nothing, sorry. Find the integers. Well, now just solve it. So 3x equals 16 plus x. I combine 14 and 2. Minus x minus x. I get 2x equals 16. Divide both sides by 2. And x equals 8. So that means my smallest integer is 8. My second one is 9. And the third one is 10. Okay. 3 consecutive odd integers, oops, make sure it's x plus 2, and x plus 4, such that the sum of the first and the second, so if I add the first, which is x, plus the second, we got first, second, third, first and second, x plus 2, I don't need parentheses because we're adding, okay, is 31 less, 31 less means subtracting 3 times the third, which is x plus 4, but it's less than, so we're going to have to make a couple of changes. So let me combine like terms here. On the left side is 2x plus 2, so let me rewrite that as that. But on the right side, I have to change the order of the terms. So it's 3x plus 4 minus 31. Okay, now we're ready to solve. 2x plus 2, 3x plus 12, distributed properly, minus 3, minus 31 or 3? It's 31. Combine like terms. Nothing here, but on the right side I can combine 12 and negative minus 31 gives you negative 18. You have variables on both sides. Let's get rid of the 2x, so minus 2x minus 2x. That goes away. I'm left with 2 equals x minus 18. We're going to do plus 18 on both sides. And I think I made a mistake. Let me just go back here. Here's my mistake. Yeah, my mistake is that I can't subtract. So here's my mistake right here. I'll tell you. 31 and 12. 12 and minus 31 and negative 31 is actually 19. There was a mistake. All right, let me continue. Minus 2x, minus 2x. That goes away. 2 comes down. 3 minus 2x is x. Minus 19. We're going to do plus 19 on both sides. And that goes away. X equals 21. So my first odd number is 21. My second is 23. And my fourth one is 25. Okay. Two consecutive integers, so in this case x and x plus 1, are such that 3 times the larger, so 3 times the larger, which is x plus 1, exceeds the smaller by 34. So if I take the larger and subtract the smaller, I get 34. That's what that means. Distributive property, 3x plus 3 minus x equals 34. Combine like terms, I get 2x plus 3 equals 34. Is it 34? Ah, okay. Sorry. I know. I made another mistake. Let me go back. Here's my mistake. Let me read the question. So 3x, so 2 consecutive, so 3 times the larger, that's correct, minus twice the smaller, 2 times the smaller, equals 34. That was my mistake. Distributive property, 3x plus 3 minus 2x equals 34. Combine like terms, 3x minus 2x is just x. X plus 3 equals 34. We're going to subtract 3 on each side, and x equals 31. So my first number is 31. My second one is 32. And then I'm going to check, which I forgot to do on the prior problem. So I'm going to go 3 times 31 plus 1. I'm going to replace x with 31. Minus 2 times 31 equals 34. Let's see if that's true. 3 times 31 plus 1 is 32. 2 times 31 is 62. That should give you 34. 3 times 32 is 96. Minus 31, 2 is 34. And notice that we are in a good place. So my 2 consecutive integers are 31 and 32. Okay, some age problems. We have Jerry. And we have Tom. This is not a future past age problem because it doesn't say in 7 years or in 5 years ago. It doesn't say any of that. So we don't need to worry about, and you don't have to create a table. But you do have to suggest that you identify the two people. Jerry's age is 9 years less than 7 times Tom. So 9 years less than 7 times Tom's age. Do we know anything about Tom? No, so he's going to be x. But notice that this will change, right, to 7x minus 9. So this is what we want to use. And Tom's equals x. Now that you identify, right, Jerry and Tom, we're going to use the next sentence because it says the sum of their ages is 39. Let's use that to find their ages. So the sum, here's Jerry, plus Tom equals 39. 7x and x becomes 8x. Minus 9 equals 39. We're going to do plus 9 on both sides. 8x equals 48. We're going to divide both sides by 8. And x equals 6. So that means Tom is 6. And Jerry is 7 times 6 minus 9, which is 42 minus 9, which is going to give us 33. We can go back and do our check, which I highly suggest you do on the test. They will ask for it. So let's take the original equation, which is this. Plug it in 6. So we get 7 times 6 minus 9 plus 6 equals 39. 7 times 6 is 42. Minus 9 plus 6 equals 39. 42 minus 9 is 33. Plus 6 equals 39. And you can tell that we are good. I need a drink because I'm very thirsty. All right. 2 more age problems. My age is 3 times as much as my brother. So there's me, and there's my brother. In terms of my brother, I'm 3 times his age, so I'm 3x. And my brother is just x. Really? Both of our ages combined is 42. So 3x. Wow. Unreal. 4x equals 42. That can't be that simple, is it? Divide by 4, divide by 4. My age is 3 times as much as my brother. Our ages combined is 42. So 42 divided by 14, that's not going to work. 10.5. I guess. So my brother's 10.5, and then I multiply that by 3. That means I'm 31.5. Let's check. So 3 times 10.5 plus 10.5 should give us 42. 3 times 10.5 is 31.5 plus 10.5. Guess what? It works. So that is 42 equals 42. I need a bonus. Bonus word, brother. I'll think. John. So we have John over here. We have Mary. John is 2 years more than twice Mary's age. So again, John is preferred in terms of Mary. So let's call Mary X. So John is 2 years plus twice whatever Mary is. That's what John is. Sum of her age is 32. Oh my God. I'll give you a few more problems tomorrow. Sum of her age is 32. So 2 plus 2x plus x, because I'm adding John plus Mary, equals 32. How old is each? Well, let's see. Here we have 3x. Oops. 3x plus 2 equals 32. Minus 2 minus 2. 3x equals 30. Divide by 3, divide by 3, x equals 10. So that makes Mary 10. And John is going to be 22. Let's just check. So it's 2 plus 2 times 10 plus 10 equals 32. And that works out just fine. 32 equals 32. I know what your bonus word is going to be. The answer to, your bonus word, in the beginning of the year, we did a problem called Noah's Ark. Right? We had an ark, we had animals in it, and I asked you how many seals were needed on the right side to make the weight of both sides of the boat even, right? That they balance out. So the bonus word is the answer to that problem. Okay, so I want you to write down what was the answer to that problem. I will post the problem up in case you forgot or you don't have it, but that's the bonus word. Okay, triangle. We're talking about angles. So in this particular case, you have to know that any triangle, the sum of the angles, we have 3 angles in the triangle. So angle A plus angle B plus angle C will always equal to 180 in any triangle. So we have first angle, second angle, and third angle. It says the second angle of a triangle is the same size as the first. So if the first is x, the second is x. The third angle is 12 degrees larger than the first. So the third angle is 12 more than the first. How large are the angles? Well, x plus x plus 12 plus x equals 180. So we're going to combine like terms. 3x plus 12 equals 180. Minus 12 minus 12. We're going to get 3x equals 168. 168 divisible by 3. Let's see, 8, 6, and 1. Yes, it is. because that's 15, so it's divisible by 3. So divide this by 3, divide this by 3. 168 divided by 3 equals 56. So x equals 56. So the first angle is 56. The second angle is 56. And the third angle is 12 plus 56, which is going to give us 68. So it's a isosceles triangle. Let's just make sure that 56 plus 56 plus 68 equals 180. And if it does, we're good. 56 plus 56 plus 68 equals 180. Look at that. And then the last question, this again, another triangle problem. The second angle of a triangle is 3 times as large as the first. So the first we don't know, so let's call it x. So the second is 3 times the first. The third angle is 30 degrees more than the first. 30 more than x. Find the measure of the angles. Okay, again, x plus 3x is 30 plus x equals 180. We got 3x, 4x, 5x plus 30 equals 180. Minus 30, minus 30. 5x equals 150. Divide that by 5. Divide that by 5. X equals 30. The first angle is 30. The second one is 3 times 30, which is 90. And the last angle has to be 60. 30 plus 30, which is 60. And then if you add these up, you'll notice that it equals 180. So that's one check, and the other check is you going back to your equation here, right? And what do you call it? Substituting. That's it. I mean, I'll look at the test, and then if there are any other questions that I think you should work on or just go review, I'll let you guys know. Okay, but for now, that's it.